This video is debunking AI model myths. And then in this video, what my goal is to very specifically go over 5 myths plus one very special bonus myth if you stay tuned through the entirety of the video to the end that are specifically related to AI datasets and AI training. My goal is to demystify all of that process for you and to go over the most common myths and misconceptions that I face and deal with and questions that I deal with on a daily basis related specifically to these things. So, diving in, myth number one. Myth number one is that you need the most performant model for all of your tasks, that you always need ChatGPT 4 or Claude Opus or whatever the most performant model is at the time. And then, so my first argument here is depth over breadth. And then, so what I mean by that, very specifically when it comes to AI, is that if you look at various models and various industries, I always bring up, and I like this example a lot because it's the one that has so far adopted AI overall very well, which is the medical industry. In the medical industry, they train the breadth of models on a depth of data. Right? So they focus on the data set depth and training that very specifically and making sure that their data sets are refined as opposed to a broad model. And then so that allows for them to refine a medical model, and for example a Llama 3 model 70B that is trained on the Stanford medical dataset will outperform GPT-4 on medical data sets, on like medical information, right? Like that's been a big paper that's been out recently. And then so just highlighting that overall, that it's much more important the data that you're training it on as opposed to the model itself. And I want to set that as the tone up front here. Furthermore, it's a big concept that people are missing within this. I think this is huge to me. Is that like 90% performant, meaning like 90% as good as the top model, is about and can be about 3,000% cheaper. Insane figures here. And then so to me, when you take that into the equation, oftentimes 90% performant is going to be more than acceptable for your task, and it's going to be 3,000% cheaper. I mean, it's kind of a no-brainer there to me. Next on the list here is that it's not even possible for the average person to fine-tune the most performant models. So as of the making of this video, it's still in beta stages to fine-tune ChatGPT 4 as an example, which is why I bring this up. And then also the most recent and kind of like the Cohere AI model. There's like models that are when it's bleeding edge, it's often harder. And there's less available resources to be able to fine tune the model anyway. And then like the newest Llama 400B model isn't even out yet. And then so that ties into this kind of the last point, which is that there's big privacy and security concerns that a lot of people have when we're talking about the most performant model. Because when we're talking about the most performant models, they're not models that you own, right? So they're not on site, anything like that. They're not like a Llama 7B or 8B or 70B model. And then so within that, it raises the question a lot of privacy and security. And then this is a lot of companies, it's like one of their number one top concerns is that they don't want to feed a model like ChatGPT 4 all of their data, and they're 1,000,000% okay with bypassing and not getting the 100% most performant model to factor that into that equation. So just bringing that up for that reason. This brings us to model myth number 2, which is like this is a huge misconception. I have this conversation like on a daily basis, which is that fine tuning is expensive. Just giving you an example, like the most common example and the most common model that you probably want to fine tune is ChatGPT 3.5. It costs you between $5 and $8, just so you know. I think like a lot of people aren't expecting that figure, right? They expect that figure to be a lot more. If you know exactly what you're doing, if you have the data set ready, you're doing it yourself, $5 to $8. That's what you're going to spend for ChatGPT 5. Not only that, but wait, there's more. If we go past that into like door number 2, we can see that there's actually lots of ways to tune models for free. Like, not just, so if we go beyond ChatGPT 3.5, we look at like Google has big programs, right? Like first time that you want to train and sign up for Google Cloud and Vertex AI, maybe $300 to train. And then so like $300 for free to train their models. A lot of like different individual inference host vendors that are out there. They'll give you free credits, things like that. And so there's lots of ways to get free fine tuning of models. And then furthermore, if you're talking about smaller models, like say like Phi 3 or models like that, those can be tuned locally, and then that's essentially like your GPU. So it's essentially, it breaks down to like essentially free anyway. There's always a cost, right? Like it's a minor cost in that instance, and you're not actually, like, you're not paying a cost directly for it. And then the bottom line, and I'll get more into this as we go further into this, but I do want to highlight it up front at this point is that so all of this is talking about and reliant on LoRa tuning. And then so LoRa tuning is essentially like training and fine tuning a small number of parameters for and over like rather than like the whole entire model, you're just fine tuning a small number of parameters. And then what has been found with that is that it's about 90% as good as full model fine tuning. And then so within that allows you to fine tune a model for about like $5 to $8 on average. And so that's kind of what we're talking about overall within this discussion, just making that clear up front. And then so moving on to model myth number 3, which is that it requires absurd amounts of data to fine tune a model. This is another conversation that I have with people almost on a daily basis. Fine tuning requires substantially less data than actual initial model training. And that's a concept that people don't understand and that they miss within this is that when we're talking about fine tuning, we're not actually talking about full training of the model. We're talking about taking a small data set and training it to be performant on one specific task. And then so within that, I've done a lot of research and there's been a lot of papers that have been released on this. And then on average, it's about 500 to 1,000 rows is optimal. Within that, like that range, 500 to 1,000 rows. Less is ineffective, and then counterintuitively, quite a bit more can be less effective as well. And then so if you take like a data set of like 1,000,000 rows and then you fine tune a model on it, it's not going to be as efficient because you're not, when you want to fine tune a model, you want to make it like very performant on a narrow niche task, right? Is kind of the goal with fine tuning overall. And then so by taking a broad data set like that, and it kind of defeats and overwhelms the model on that purpose. That's just my results of my findings, and a lot of literature backs that up overall. Moving on to model myth number 4, which is that it's hard to curate the perfect data set. And then so the very first thing that I want to say up front with this, and I say this very clearly oftentimes around this subject, is that like when it comes to like ChatGPT 4, like Claude Opus, like all of the most performant models that are currently in existence, they're not going to tell you directly up front, but I guarantee like 1,000,000% that these models were trained on. There's a data set that's been floating around for like 2 years. If you know anything about AI and you know what you're doing, it's easy to find it. And it's the Reddit data set, right? It's like the biggest data set that you can find, which is why it's so well known in AI training communities, right? But so it's Reddit data, like just flat out, like everything that you can think of with regards towards Reddit data. So we're not talking about like rocket science. We're not talking about textbooks overall, right? And then what has been found is that textbooks are more performant and a lot more performant than the data that the models are trained on because they're trained on Reddit data. And then so overall, just framing that like your bar is low up front to clear, and then secondarily, I think like a lot of people don't realize this, that the best data sets are repetitive task examples, like repetitive examples of exactly what you want the model to do, exactly what you want it to classify, what you want it to predict, what you want it to type out, the type of tone that you want it to take, instructions, all of that, like very repetitive over and over. That's going to perform you the best more than anything else. And then so it's just, especially if you're talking about like corporate uses and like a very niche example, then you want to give it a lot of examples of that niche, which is perfect for like in this instance entrepreneurs. And then so the last thing to dive into within this is that synthetic data can augment real world examples. And then so a lot of people don't understand this, and then there's a lot of like misconceptions and a lot of like arguments around all of synthetic data versus like actual produced data, etc. And then so to me the bottom line overall is that like 99% of my data sets are what I would call and consider a synthetic blend, which is I take real world data and I blend it and I make it exactly how I want it to be, which is in most instances prompt response pairs for the outputs and for the training outputs. And then I also augment it with synthetic data. I take like real world examples, and then if I have 200 of them, I turn it into 500 for the training that I need, right? Like, and then doing that is oftentimes like 98% again, like of the results of doing the real actual thing. And then so that moves us on to model myth number 5, which is a big one. I hear this a lot, and this is like I don't deal with this one on a daily basis. I deal with this one on like almost every executive that I work with. I deal with this at some point in time, which is that rag tuning equals fine tuning, and then like the best example that I can give it to you up front is instructing versus training and the difference there, right? And then so if I hand you instructions on how to fish versus I train you, like I take you out to the pond and I give you a fishing pole in your hand and we go out and we do it, there's those are two different things. And it's the same thing with AI as well. And then that's the difference between rag tuning and fine tuning. And then so saying they're the same is the same that it's the same as giving you a set of instructions to fish as opposed to taking you out to fish. And while they're similar and they're in the same category and they're in the same league, they are two very different things. Furthermore, what happened like and I guess to highlight that and to give the warrant behind that, the major difference is updating the embeddings versus not updating the embeddings, right? And then that's like so like it's when I talked about like LoRa tuning, right? When we're fine tuning a small number of parameters, but we're actually tuning those parameters, tuning the embeddings based off of the data. Whereas with rag tuning, you're not actually tuning any parameters. You're just saying, here's the data. And then so it's again like that. It's instructing, but not training. And then so going down to the next argument here, it's that there's more tokens. When you're talking about rag tuning, you have more tokens for every prompt, and that gets really expensive very fast. So let's say that you're rag tuning on a document every single time, and let's say the document is 30,000 tokens. That's I won't make it like unreasonable, right? And then so it's like a company white paper, and then you pass that company white paper every single time you ask the model a bunch of questions. And then so like over time, let's say like ChatGPT 4 is $35 per million tokens, around there, like averaging out, right? And then so if you're passing 30,000 extra tokens per time, and then let's say that the output is 2,000 tokens, or 3,000 with the output and the input. We'll say it's 3,000 tokens, right? We'll combine them together. So you're literally like you're adding 10 times your cost when you're talking about a cost per token basis by doing rag tuning, and then over time these costs add up, right? Like it's small numbers, so I think it goes under the rug, but like people are going to be paying more and more attention to cost per million tokens and how many tokens you're actually passing to these models, because that's what matters at the end of the day more than anything else. And it matters. It's going to matter to you as a consumer, and it's especially going to matter to you as a consumer because especially as more and more providers start passing on that cost as the calculation, right? And then the last thing to highlight, and this goes back to that tuning of the embeddings, right? That it doesn't actually happen, is that with rag tuning you have a man in the middle problem. And then there's models that like the people will say that like Claude Opus is like has this 100% solved. Like there's like be wary of anyone that says like any of these problems are like 100% solved. There's generally not going to be a situation with regards towards like AI, like big situations like this where it's actually 100% solved. And like Claude Opus is no exception. Claude Opus is better than other models with this problem, but this problem still exists. And then so just highlighting it very clearly. The man in the middle problem is where you give it, let's say, again, like a company white paper or a book, and then you ask it about the middle sections of that white paper or the middle chapters of that book. And then the model will have more of a problem giving and recalling information from the middle of it than it will from the beginning or the end. And it's just how the attention mechanism works overall with the models. And so it's an attention mechanism problem. And then so that brings us to the bonus myth number 1, which is that there is no resource that exists that's entrepreneur-centric regarding AI. And then so a lot of this video, I very specifically have geared this video towards entrepreneurs. And then so this is upfront plugging one of my essentially a bundle for entrepreneurs that I've created, and I'm not going to call it a course because it's far more than a course. It's a AI for entrepreneurs intro bundle, and then I'll leave a link to it in the description. It includes white papers, lectures, books, guides, and worksheets. Essentially everything that you would need to get into AI, and it's designed to teach you very quickly what you need to know about AI without any of the technical jargon, very specifically geared towards entrepreneurs. And then more importantly, it includes several things, but it includes unique bonus and business ideas and how to implement them very specifically. And a lot of the content that I went over in this video is very specifically related to and comes from is like a distilled version of what you can find in a few of the white papers from this particular entrepreneur bundle. So if you want to check it out in that description, and if you like this type of content, please like and subscribe. Thank you very much.